Oh, here they are.
I got 0.
Ah!
I know what you're doing.
You do?
I know what you're
You're
doing.
doing dice right now. I know what you're doing. Know what
Your game.
I'm onto your games. All my games are, my friend. I love that you call them that. I love that you call them that. All my games are is testing hypotheses. I love testing hypotheses. Yes, I love testing hypotheses. Let's collect some data. I love collecting data to test hypotheses. Christy had an awesome hypothesis. If you roll a die 6 times, you're gonna get 1 6. Let's test it. No. Let's test it.
You're likely.
Oh, we're likely to get 1 6. Okay. So let's collect some data. Let's make a chart. Number of times we saw 6. Because you roll the die 6 times, right? Each of you roll the die 6 times. What's the least number of times you could have seen a 6? 0. Could you have seen it once?
Yeah.
Could you have seen it twice?
Yeah.
Could you have seen it thrice?
Yeah.
Is there an ice version of 4?
Thrice.
Thrice? 4, 5 or 6 times. There we go. Good enough. Raise your hand if you didn't see 6 at all. 1, 2, 3, 4, 5, 6. 6 didn't see 6 at all. A lot of 6s. Once! 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm seeing this likely pop up here, Christy. Very good, very good. 2 6s. Interesting. 3 6s. 5. No.
4.
1, 2, 3, 4. 4 6s. There we go. Getting off. Nobody saw 4. Anybody see 5 or 6? All right.
You did go to Vegas now.
Calculate, if you would be so kind, the average number of 6s we saw. Calculate the average number. Use a weighted average. Remember how to do a weighted average? Of course you do.
No, wait.
0 times 6 plus 1 times 9 plus 2 times 5. Everybody following this?
Yeah.
Does this ring a bell from last week?
Yeah.
Hopefully it does. This is, FYI, it's more than expected value. We're still hitting that expected value idea. 2 times 5, 3 times 4, yes? All over, I get 24, is that correct? 15, 24. So let's see, that's 19, 21. Check my math on this one, friends. Check my math, make sure that's right. It's not right. It's 31.
31.
It's 31, not 21. And I can't do that in my head. 1 point something.
1.291.
Thank you! Thank you so much, Britt. 1.29 is pretty damn close to 1, isn't it? If you round to the nearest whole number, it would be 1. But now, what Christy said was, you're likely to get 1 6 out of 6 rolls. And you're likely to get 1 6 out of 6 rolls. We just averaged 1 6 out of 6 rolls, but Christy herself got 3, which is interesting, huh? And a bunch of you got 0. If you would, do it again. And then do it again. So roll the die now 6 times, again, and keep track of the 6s you get. And then do it again, and keep track of it. So do it 6 times each. So 6 times, keep track of the 6s, 6 more times, keep track of the 6s. Let's collect a little more data. If they fall on the floor, count them. Count it to me. Still random. I happen to love what Christy said. I just want to kind of add 2 more words or 3 more words to it. Say that again. Right, so roll 6 times, keep track of how many 6s, then roll 6 times again, how many 6s. Does that make sense? So in essence, we're doing that experiment 2 more times. How do you think our results are going to compare to the last experiment?
Pretty similar.
Totally different, but pretty similar. I love those. So exactly the same? I don't know. Let's find out. In the first time you did it, no 6s at all. How many times? No 6s at all the first look at that. Only, 5. Okay, 6. Look at that. That's fun. Okay, how about 1 6? All the hands go up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay.
Will you count me in as a 0?
Did you have your hand up?
No. Yeah.
Yes, I read your mind. I'm really good at that. I'm reading all of them all the time. 2! 2 6s! 2 6s! Christy, once again, you're broke. Now good. 1, 2, 3, 4, 5, 6. 3 6s! Oh. 2, 3. 4 6s! 5, 6. Okay. Now, look at that. Look at that. What did I do? What did I do?
I threw it off.
You threw it off.
I gave you both of my rolls.
Oh, you did. So Pam, where were you?
All right, so I got 1 on the first roll.
And
Now,
so
what
you
did
voted
you-
for.
I voted for that one. It was the second one, where there was 2. That should have been my second roll.
So
So take
11.
one of these away
Yeah.
and add 1 to here.
No,
No, just take it away.
the next
This is just our next roll, right?
Correct. And we'll do the next experiment, which is the next 6 rolls. Well, look at that, friends. That's almost identical to the first experiment, isn't it? It's damn close.
Yeah.
The most were still 1. Yes. But we had this cool little bell around it. Yes. What are you guys? We may have a different number because we were coming in a little bit late. That's possible. That's okay. Hey, how about the next 6? Next 6. Now let's do the next 6. How many got no 6s on the next 6 rolls? 2, 3. Only 3. Oh, 4. 4. 1 6. There we go. Christy got it that time. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Will you add 1 to the 0?
Yes, of course. 2.
3s. Oh, wait, 2s.
2's now. Yeah, 2's now. Is that 8? That was. Yes, that was 8. 3s. Oh, just 1 this time. 4. Oh, we got a 4 this time. Oh, 5s, 6s. Okay. Noisy data, yes? But there's an underlying pattern, isn't there? If you were to calculate the average of all 3 of these experiments, what are you going to notice about it? You're going to notice they're all pretty close to 1. So, Christy, how did you define what a probability of 1 6 meant?
That you should see a 6 once in 6 rolls.
At
But I
2.
would like to add, you're likely,
Oh, no,
possibly likely, to
no! But just add 2 more words.
Possibly like.
And you then leave the likely out.
on average.
Oh, on average.
On average!
Likely to get it 1 out of 6 times.
That's all I needed to hear! If you add that in, you're golden. On average, that's what a probability is. This goes back to Desiree's idea about trying to predict the next flip or the next roll on a previous one. You can't, because on average, what's going to happen next is most likely not what just happened. It can happen, and they do clump. But that, unfortunately, that behavior isn't guaranteed with any kind of regularity. That's all the probability means. Thank you, guys. Wonderful, wonderful, wonderful. And thank you for saying that, Christy, and spurring the experiment, which is really, really cool. So when you see